Welcome back guys, welcome to my Geek Verma channel. Let's start with my new series on how to prepare for farm. In this playlist we will cover as many as LeetCode problems to practice. So let's first start with a diagonal traverse problem that is related to arrays and string. As you see, we have given a matrix of 3 cross 3 2D arrays. We have to output the diagonal elements of this matrix. Let's understand with some. Okay, let's start with understanding how this diagonal traverse problem look like. Suppose we have a 3 cross 3 matrix like this: 1 2 3 4 5 6 7 8 9. Here we have a 3 cross 3 matrix look like this. Each one have 3 rows and 3 columns. For sake of clarity, let's index the columns from 0 1 2, and similarly to the rows 0 1 2. So to get started, let's understand that in a matrix like this of mat, we have matrix like this. That it has 0 index and 1 index. So we need output like we have to traverse a diagonal. Once we move to a diagonal, we will cover the element like this. Here what we are doing is either we are moving up like this point, or we are moving down. So you have to keep in mind that whenever you are moving up, you will take a first right, and when you are moving down, you will take a left. So let's start from here. So whenever you are at position at 0, this point at the beginning, we will always move up and we will take a right position. By doing so, we will land at the position where rows is invalid. Here the rows is -1, which is not fine, but the column is valid, which is under the 2. The max the rows and columns max length will be, in this case, will be 3. So column will be under the 3. So at this point we will have to move down by appending the rows to 1, and when we move at this point, here again we are at invalid position where column is at -1, rows is fine. So fix that, we will append the column to by 1, and we will put this number to our output. Similarly, while we traversing, we reach here at the point where column exceed this value. So here what we do, we will first negate the column value by 1 so that it can reach the matrix boundary, and append the row value by 2. So this is the case where columns exceed the current column values exceed the value of column length. Similarly, at this point, when we move from 8, we will reach a point where we exceed the value of rows. Rows values will be current rows value exceed the value of current rows length. At this point, current rows value might be 3. So therefore it is exceeding this value. So to fix that, we will again negate the rows value by 1 and move the column value by 2 so that it can land here, and after that we have to stop traversing. So I hope you understand with this explanation. The rest we will cover while in the code. Okay, let's start with implementation of this diagonal traverse problem. So I have already written one solution for it, and before moving up, let's discuss some constraint. M here is considered as a mat length, that is, we can say the array of length of an array. N is considered as a column, so n is considered as a column size. The value of m and n should be constrained between 1 and to the power of 10 to the power 4. The m times n value should be constrained between 1 and 10 to the power 4. So these are some constants you should look before moving up. So I have written some code for you. So let's start how I have implemented this solution. So at the beginning, I just mentioned rows and columns. That is, we are taking its size, rows and columns, as length of size of mat arrays and size of mat first index array as column. So this is how we define the rows and columns for this array. And once we traverse along the diagonal element in this array, we have to know the current position of our rows and columns. So that will help us track our element. So for that, I have taken the two variables, current row and current column, and initiated value as 0. So to output all the end list, I have taken one list called res that will be act as an output list. And as we have seen in the implementation of this problem, we either move up or down. So to track the status of our direction, I have taken a variable called growing up and set it as true. So we have this master while loop that is set as length of res, that is this output list, should be not equals to rows and columns. That is because we want to take the element that is inside this boundary, so that our output list should be confined to this array only. So in order to keep our so that we should not consider anything outside this matrix. That's why I have taken this logic, that is our length of res not equal to rows times column. So after that, we have, if the growing up variable is set up, we will look for the case that is when we are growing up, for the case of 1, 7, 5, 3 and 9. In that case, see carefully that in every case when we are going up, the number of the current rows have to be greater than 0 only, and the columns should be less than the maximum size of column. The current columns should be less than current size of column. That's why I have taken this condition, like current row should be greater than equal to 0 and current column should be less than column, and for that variable should be append to the output list in res. If you see carefully, this line help to pick this element 1, because this element is at position 0, 0, that is 0th row, 0 column. So that matching perfectly fine for this condition. So that's why our the first element 1 is output to this list. Next, we will check in this condition while traversing, if our current column have not exceeded the column size. So if that happen, we will negate the column by 1 and append the rows by 2, because after moving 3, we have to traverse the rows to pick 6. We have to move by row by 2 times, and we have to get into this matrix, we have to negate the column by 1. So what I have done here. If not, this not the case, suppose whenever we was here, suppose when we have moved after 4, we will came here, and after that we have to move up. So what we have to do is, our current row size is fine because it is 2, but we have at this position it have invalid column value. So to fix this, we just need to append the column by 1 so that it can get into this matrix. That's why I have used this current rows by 1. I fix this current row by 1, and at the end I have just put the growing up variable. I have negated, inverted it, so that when we after we have move up, we have to, and if we have exceed the boundary, we have to change our direction. So that's why I have used this growing up as false. So same thing, whenever again the loops move ahead, again now the length of res is now 1 because we have put the first element. It still is less than not equals to rows and columns. Now in this time this will move to this else part, and here we have using the same condition with some slight difference. Here I am using current columns if it is greater than or equal to 0, and current rows is less than size of rows. We will append the mat to this output list. What will happen here is, when we have the time when we have moved above from this position, we have reached the position where the rows is get negative and the columns is fine. So here we have appended the rows by 1 so that after here we can move to this boundary. So at this position we are picking the value 2, and down after we have to pick 4. So that's why this current rows plus 1 current column minus 1 will pick this value 4, and after that the while loops again move. It will put the iterator to here in this position where column size get invalid value but row is fine, and again we will active the grow up variable to true, and again this loops while loops continue because of now the length of RE is 2, but it's still less than this multiple rows times column, and because growing up is active now, so it will move ahead again this like this, and it will pick the 7, 5, 3 and so on. Let's say this is that my implementation works or not. I will use run button. Yeah, see, it is fine, it is run as expected. Let's take some other example to test it more clearly. This time I will choose 2 item 3 and 4. Let's see is that work now or not. Yeah, it's work fine. I think we have tested enough. Let's try to submit it again. Submit that solution to the yeah, see, it is accepted. So this is the solution for this diagonal traverse. Let me comment how you like the solution or not. If you find anything more explanation, comment me down. I will give a clear explanation for that your query. Thank you for watching.